This is example number 2 for foundation design for shallow foundations. The problem statement that we have is we have a continuous footing that is 0.75 meters wide, and it supports a vertical wall loading of 120 kilonewtons per meter. The distance from the ground surface to the bottom of the footing is 0.6 meters. If the groundwater table is 15 meters below the ground surface, calculate the bearing pressure. So here's our figure. We have our applied loading of 120 kilonewtons per meter over here. And we show the ground surface, and D, the distance from the ground surface to the bottom of the footing, is 0.6 meters, and the width is 0.75 meters. So since this is a continuous footing, we're going to express the applied loads as a force per unit length. So that's why I've shown this B over here. This is our 1 meter long strip that we're considering. So that's why the applied loads will be as a force per unit length. So the first thing we need to do is calculate the weight of the foundation, including the weight of the soil above the foundation, if any. So this is going to be equal to the width of the foundation multiplied by the depth multiplied by the unit weight of the foundation. So since this is made of concrete, reinforced concrete, the unit weight is 23.6 kilonewtons per meter cubed. And the depth we're taking as 0.6 meters, that's the distance from the ground surface to the bottom. So we're being a little bit conservative. In this case, we're assuming as if the concrete extends from the bottom all the way to the ground surface. Even though you have soil over here, there's going to be soil above the foundation here and here. But to avoid using two different unit weights, one for soil, one for concrete, we just assume this is all concrete. So this is being conservative, but the error isn't too big. So we just go in and simplify things that way. So our unit weight of the foundation is going to be 10.62 kilonewtons per meter. Next, we consider the pore water pressure at the bottom of the foundation, and in this case it's going to be 0 because the distance from the ground surface to the water table is 15 meters, while the distance from the ground surface to the bottom of the foundation, which is D, is 0.6 meters. So whenever D is smaller than the distance from the ground surface to the water table, then the pore water pressure will be 0. So once we know that the pore water pressure is 0, now we can just go ahead and calculate the bearing pressure. And this is going to be equal to the weight of the foundation per unit length plus the applied loading, vertical loading per unit length divided by the width, and then minus the pore water pressure, which in this case is just 0. So 10.62 kilonewtons per meter plus 120 kilonewtons per meter divided by 0.75 meters, the width. So this gives us 174.16 kilopascals. And this is the end of this example. I also made a spreadsheet. I'll post this on the website at engineeringexamples.net. Everything in yellow is input, everything else is output. And also, please don't forget to subscribe to the channel. Check out our Facebook page. It's facebook.com/engineeringexamples. Thanks.